Hi, Professor. My name is Kakai, and I'm going to work through the 5 problems for assignment 1. So the first problem is insertion sort. So to me, insertion sort is like inserting the books into the bookshelf. We just need to make sure each book is on the right position. So take and read, for example, 23157, and we want to sort them into increasing order. And we always want to compare the numbers to its left numbers. If it's smaller than that, we will need a swap. So we start from 3 as 2 doesn't have number on its left. 3 is larger than 2, so we don't need to do a swap. Then we take 1. 1 is smaller than 3, so we will swap 1 with 3. And we do the same thing. We compare 1 with 2. 1 is also smaller than 2, so we will swap 1 and 2 as well. So we get 1, 2, 3. And for 5 and 7, we will do the same thing. We will only do swap if needed. The worst case scenario for this is when the given array is in decreasing order, so we will need to compare and swap all the numbers. The runtime efficiency for this is O(n) squared. N represents the size of the array. And the complexity classification for this is P because it runs in polynomial time. Now it comes to the second problem, which is traveling salesman problem. So it's aiming to find the shortest route for a salesman to visit all the cities. For example, if there are 8 cities, so how many routes are there? So we pick a random city and then we will have 8 minus 1, which is 7 choices for the second city. And then we'll have 6 choices for the third city, and so on. So in total, there will be 8 minus 1 factorial different routes in total, which is 5040. And the runtime efficiency will be n factorial. Of course, if we're using dynamic programming, it could be less than this, but in general, it's still n factorial. And the complexity classification for this problem is NP hard, as it is at least an NP problem. The third problem is to find the sum of all the values in a 3D array. And the 3D array is n times n times n. So the solution to this problem is simply iterate all the numbers and add them together. So the runtime efficiency for this is O(n), and n represents the number of items in this 3D array. So in our case, capital N equals to lowercase n times n times n. And the complexity classification for this problem is also P, because it also runs in polynomial time. For the fourth problem, radix sort. So for example, if we have this given array of numbers, we want to sort them in increasing order. So what we want to do is we want to using the counting sort on each digit of the numbers. So the first step is to sort the given array using counting sort, and the keys would be the last digit of the numbers. So in our case, it would be 3903633. Sorry, it's 390633. And we will sort the numbers using the counting sort and rearranging them. And then we were using the counting sort again for the second last digit. And we will repeat this until we have sort the numbers for all the digits in the largest number. How many times of counting sort do we need is depends on the largest value. So in our case is 633. So in our case we are using decimal system. So it has 3 digits, which means that we will do 3 times of counting sort. So if B represents the base of numbers, if we're using decimal system, B will equal to 10. And n represents the number of items in the array, and k represents the largest value because the number of counting sort will depend on this largest value. So for each counting sort, runtime efficiency is O(n) plus the range of key, which is b. So it's O(n) plus b. And the number of counting sorts we need to do is log b k. So we times them together. The overall runtime efficiency would be O(n) plus b times log bk. So in ideal time, it could be like n times log n, which is similar to quick sort or merge sort, but still, but it's very hard to achieve that. It really depends on the base, the base of numbers, and also like the largest value. And the complexity classification for this is P. The last problem is brute force for a password cracker. So the solution is we need to try all the possible choices on each digit of the password. For example, it could be numbers, it could be lowercase alphabets, or special characters. So the n will represent the number of choices on each digit, and c is the number of password digits. So for example, if there is a 6-digit password, it could only be numbers from 0 to 9, so it will be 10 to 6 choices of password cracker. And the complexity classification for this problem is also P, as it is also need polynomial times. So that's all for 5 problem. Thank you so much for the time.